This is a iron pipe. I think it's understood, no? Iron means metal, pipe, hollow. I'll drop into that one. And it's a long iron pipe. And this end is you put better infinity. This end I should not put infinity here because I should drop from finite, no? It's a very long iron pipe. What will be the motion of the bar magnet? Take the effect of gravity. Gravity will be there. Just bring the bar magnet inside the pipe. Initially, why do it will move down? Why do it will fall down? Because of weight. Because of weight, it will fall down. As it falls down, then it will encounter a rings, no? Similar, the same earlier idea you have to apply. It will encounter rings. There will be rings above the bar magnet, below the bar magnet. Those rings which are above, those rings which below. What condition they'll put on the bar magnet, that we have to see. This is the upper part. It's a long one. It's a long pipe. So the bar magnet, let's take somewhere in this position. South, North Pole. The weight of that. W, let me write it here. Those rings which are above, those rings which are above, in what action they'll exert a force on it? Those rings which are above. So how the direction of current will be? So apply the same similar concept. How the direction of current? Anti-clockwise. Current in this part of the those rings which are below. Okay, I'm showing this current I. Is it okay? No. So in the upper part of the bar pipe, the current will be flowing in this, and the lower part, the current will be flowing in this direction. I'm showing things clearly. Just do notice. So put that current, need not be same, call I1, I2. What this I2 will do, will exert a force F2 like this. What about this particular thing? It will also exert a force, no? Both will exert. F2 will be attractive. The upper part will exert a force F2 on the bar magnet. Upper part of the bar. The lower part, what will be exerting a force, that will be a repulsive force, that will be F1. What can happen here? So this will have velocity V. So it will accelerate, no? So then what is the equation we can write? Ma is equal to, let me write mg. Mass of the bar magnet, mg, minus F1 minus F2. Now, what can happen? What are F1, F2? Will they depend on the position as it keeps on? Initially, what when the release from rest, now what are F1, F2? 0. So as the bar magnets accelerates, what can happen to value of F1, F2? I think this we don't have any information, no? How to predict that F1, F2? F1, F2 on what factor depends? Force of interaction between the ring and the bar magnet. With the time, what will happen to the bar magnet? Its velocity continuously increases, no? And as the velocity increases, and what is that induced current due to rate of change of flux? What is induced current? Induced current I2, I1 or what they are? They are rate of change of flux. And the rate of change of flux depends on what? Depends also on the speed of the bar magnet. If the speed of bar magnet increases, what happens? More rate of change of flux, more rate of change of flux, then EMF induced more, then induced current is more. Then if induced current I2 is more, F1, F2 will increase. So with the time, F1 and F2 increases. Now what is maximum permitted value of F1, F2? Finally, what when the F1, F2, when the resultant of these two, when it becomes equal to G, the net force on the bar magnet will be 0 and the bar magnet will continue to move with a terminal velocity. After long time, after a long time. So what is the acceleration of bar magnet will be 0, and the velocity of this will be, I'll call terminal velocity. It is similar to viscosity. F1, F2, F1 and F2 are dependent on speed of bar magnet. Is it justified? Because you do one thing, that ring is a one current carrying loop, and this bar magnet is also some current carrying loop. You go back to the basic thing, force of interaction between two loops, as we can find out here. The interaction potential depends also on the distance and also the speed here now. And the I2 depends on speed. As the speed of the bar magnet increases, I2 increases, then F2 also increases. As the speed of bar magnet increases, the rate of change of flux linking the lower part of the pipe will increase. Then induced current I1 will increase.